I will say this class wins the award for the most number of brought lunches and stayed in the room lunches, so well done. Okay, so we're going to talk about ecosystems for a minute. And I know that the program talks a lot about plant communities. And those are certainly one element of an ecosystem. But to me, that ecosystem definition is much broader. And here's what Wikipedia says: a biological environment consisting of all the organisms living in a particular area, as well as all of the non-living physical components of the environment with which two organisms interact. CJ. I guess I never read that out loud before. Such as air, soil, you get the idea. So it's the inert things and the living things. Everything together makes up the ecosystem. And this is, 8th grade science, more or less. But I really like this. I Googled what is an ecosystem. How did teachers teach before there was the internet? I am just so grateful to have it. When I first started teaching the plant ID classes, there wasn't much internet back then, and it was much different in preparing materials. But what is an ecosystem? This is what NOAA says. And I love it because they have everything from the tidal mixing of nutrients and old carbon, and nutrients come in, and there's the natural horizontal things that happen in the ocean, as well as the vertical things that happen in the ocean. So all of those forces working together, they're including in that definition. And I like that because it's the full of what makes an ecosystem work. The other thing I like about this is that they add the human elements. This says tourism, recreation, commercial fishing, sport fishing, subsistence. I could never say that word. Subsistence. Food, basically. Okay. And coastal communities. And the humans' impact as part of the ecosystem. So I like that as, remember we were talking about humans and nature both being respected and included. I think this is the best illustration of an ecosystem that I've seen. Well, and how big is an ecosystem? How is it delineated? Well, it's really, the scale is indefinitely large and small at the same time, if that makes sense. So here's my house, my old house in Maryland, just to the south on the maps that we worked on, right? So what would be the ecosystems on this property? Well, we've got a stream going right down through here. It's flowing from west to east. There's a wetland down here, really steep slopes. We've got two patches of evergreen trees, white pines. So their little ecosystem with them is very different. They usually don't have plants that grow under them because they shed so many needles every year. So it's very, so it could get as small in defining an ecosystem as something like that, if you were so inclined. This is also a north-facing slope. We're going to talk about microclimate a little bit, but north-facing slopes are particularly difficult. Plants grow slow, you don't get a lot of sun. Our driveway went up this side. All winter it was perpetually ice. We mostly parked at the bottom and walked 300 feet up to the house because it was just, that microclimate was such that it never thawed out. So just thinking about how those plant relationships, those community relationships work. And I don't think ecosystems as a term is something that is so used throughout the program. They talk more about plant communities and, it's more vegetation oriented. But it's important to know, like, what are you talking about when you're talking about, these plants? So define native plants. A plant that has existed in an area before the Europeans settled. Well, that's a reasonable amount of time, right? Several hundred years. And, go ahead.
I was gonna say, some would take even exception to that,
Yes.
because if you're looking at a whole ecosystem with the insects took millennia to adjust to the vegetation and used to vegetation.
Mhm.
That's a lot longer. So, you know, what you have are adaptive plants then that the insects started to adjust to.
Mhm.
And that gets you into a whole nother area. But usually people only look at hundreds, but now the new thinking is looking back even further.
Cool. Yeah, and the problem with a lot of plants in this area is that some of them have been in this area for 200 years. You know, half the time that what we're talking about here, because they were introduced from Europe or something because of human intervention. I think what they're trying to say is at that cutoff is kind of the cutoff of human intervention. You know, other than what the native peoples did in burning the prairies and, you know, keeping that ecosystem going, that was certainly human intervention. Or supporting the natural systems, as it were. So yes, native plants definition can be debated. And then you have invasive plants, non-indigenous plant species that adversely affect the habitats and bioregions they invade. That adversely affect, hold on to that phrase, that adversely affect the habitats and bioregions they invade, economically, environmentally, and or ecologically. That's a mouthful. So the definition of invasive plants is very much debated. And some invasive plants, it's not that hard to identify. People know who that is over in that picture? English ivy. English ivy grows like crazy. It's nuts. It takes over anything it sees. Just like this friend, bamboo, not native, forms root mats that are just impossible. People have used gasoline and dynamite and all kinds of methods to try to get rid of it. So what I want to circle back to in the definition of invasive plants is adversely affect the habitats. So let's talk about a plant that is not particularly invasive and does not adversely affect. So plant people, hit me with a plant that's not a kudzu, it's not a multiflora rose, it's not something that we know takes over in these forested areas.
But it's not native?
Right. Well, that's another story, but is it invasive?
Oh, you wanted
What do you want?
examples of invasive?
Of an
Other
invasive
examples?
that
Oh.
is not voracious, not aggressive,
Mildly invasive.
mildly invasive.
But isn't it really a matter of time? So, like, I could name a plant that people are just beginning to think about as invasive, but like, you know, if you wait 20 years, it's going to be much more aggressive.
Not necessarily, because plants don't change how they grow. A plant it's its own genetics. You have to make the environment desirable for it, which usually means disturbance. Here's what I'm thinking of is, there's a whole bunch, like Mahonia, Berberis, burning bush, you know,
But those are
Burning
those
bush
are
is now-
common
It's very
landscape
invasive.
plants.
Nandina is one. Nandina is one that
That one's a little more aggressive.
it,
The point I'm trying to make is that they're not all the same. And when we talk about invasive plants, I'm just trying to make the point that they're not all everything all the time. I wish somebody would come up with a rating scale for invasive plants. I know people haven't done it because then it lets the Home Depots and the places off the hook for selling Nandina and other things that should not be sold at garden centers. But we're winning that fight. That's through education, that's happening. They're selling fewer and fewer invasive plants. I wish they'd stop selling forsythia. That's like, if If you ever took my plants classes, you never forgot that I hate forsythia. But anyway, you know, it's pretty for 1 week out of the year. The rest of the time, not so much. So these invasive plants have different levels of aggression. So when you're dealing with a restoration plan, do you go in there and, you know, every single invasive, we're going to kick its butt, we're going to spend all this money, or do you go in with a targeted approach and say, okay, if it's multiflora rose, or it's kudzu, or it's
Honeysuckle.
honeysuckle, that's another good one. These aggressive invasive plants absolutely should come out. And this is, you know, my own opinion. The opinion of the university or other instructors may be different. But you've got a limited amount of money. So how much do you spend on going after a particular plant? And, you know, herbicides are certainly something that, for some plants, are the only thing you can do. And sometimes it's the best thing to do, to just herbicide everything, make sure that it goes down into the roots, get rid of it, you're done. So you will talk about invasive plants as you go through the program, and that'll be interesting to see how your thinking on it might evolve. So then you also have exotic plants. Now most texts and definitions will say, see invasive plants when you're talking about exotic, making those equivalent, and they are not. Just because a plant is from another continent, you know, I can't wait to travel to Japan and China and see these plants in their native habitats. Wouldn't that be cool? All the ones like the Chinese junipers and the, help me out, anything that has a chinensis in its name, or the japonica, you know, it's like, wow, it would be really cool to see these plants, you know, where they grow. So it was Pieris japonica that I was thinking of. What's the common name? Used to be Andromeda, but that's not what they call it anymore. But anyway, it's an exotic plant, meaning it's not native plant. But it's not necessarily invasive. And this plant, to my knowledge, is not invasive. Hey. So you don't have to be both. Just because you're exotic doesn't mean you're invasive. Does that make it sense? Okay. Because it's too quick to jump from, oh, it's it's not a native plant, so we shouldn't plant it, period. If you went into a garden center today and said that to every plant that was in there, if you're not native, I can't plant you, you go to nurseries. What's a guess on a percentage that you would be able to use of native plants, just on a,
I'd say
wholesalers?
25% or less.
Yeah, would be plants you could use, right? And we'll talk throughout the program about how you get nurseries to grow these plants. And the cool thing is, in the last 10 years, nurseries are sprouting up all over here all weekend, ladies and gentlemen. Yeah, they're starting to grow stuff. And the problem is that growing plants takes a long time. So to get our friends who are just adamant about black gum. This was a tree they wanted to see more of. It's very tolerant of all different kinds of conditions. It grows in swampy conditions, but it's very tolerant. And they were like, why doesn't our nursery carry this tree? So every time they went in the nursery, without fail, they went up, and whoever was there, they would just say, this was Merrifield Garden Center, they'd just go, why aren't you carrying black gum? You should carry this. And sure enough, they started carrying it. They got 2 and put them in their yard, and they couldn't have been happier. Beautiful fall color, nice structure, great tree. But if you can't find it, you can't plant it. So we need to encourage those nurseries to do the right thing, grow more stuff. So I'm curious, before we talk about ecosystem services, who had heard this term before?
Ecosystem?
Ecosystem services. You heard that before? Yeah, an environmental degree. We're not, you don't get to answer this question. Okay, so you know about this, but the idea is nature nurtures us in so many different ways. And part of talking about ecosystem services is saying, we need to name these things so that we pay attention to them. And you know, there's an old adage about you don't care about what you don't measure, right? If you measure it, you care about it. Do you remember how that saying goes, Carolyn?
It's something.
Something like,
yeah,
if you don't measure it, you don't care about it, is the concept. But
What's important.
so if you're measuring ecosystem services, doggone it, that means you care about them. And that's what's really important in trying to convince people in moving the ball forward, that these things have value. Nature isn't just out there just being all, you know, nature-y. And that's why there's one word in that definition. Read that definition to yourself, and then just hold on and look at what one word would I cut out.
Free?
Free. They're not free. And when you say they're free, they have no value. So they are not protected. They are not nurtured. They're not restored. Yeah, they're not free. And in fact, okay, well, let's go through this part first that I have, yeah. So let's go through this. This is a lot of different organizations break down ecosystem services, but these are the 4 basic types of services, okay? And the one that we always think about is provisioning services. So, the landscape ecosystems provide us food and water and raw materials, or the things that live in the forest, you know, get eaten by the things that we eat, you know, whatever it is, we're all linked. And we can provide that, you know, level of nurturing directly through our bodies. Okay, so it provides provisions. But what else does? Yeah, so raw materials, says it right there. So building materials, 2x4s, houses that are stick built with 2x4s. Not a very strong house, but it's how we do it, right? So there's so many other sustainable ways to build beyond 2x4s. To me, that's not a sustainable thing. Although it is a renewable resource, we can keep building, or we can keep growing 2x4s. But, you know, we need to find other ways to do shelter. So then regulating services, how does the ecosystem regulate for us? Watch this progress. You don't need to see the numbers or anything. The idea is how much red. These are global flooding events every year from 1985 to 2007. So just look at how much red is on the map is the thing to see. These are global flooding events every year. Now what happens when there's a flood? We certainly know. But what happens to humans? We lose all our possessions, but I don't know how to lead you to the answer, which is diseases in floodwater kill people. It's not just Hurricane Sandy came in and wiped everything out. Sewer lines were broken. Water lines were broken. Sewers backed up into people's houses. Have you ever had that happen? Like your basement floods and it's sewer pipes back up into your basement. It's the most disgusting thing. Our house used to do that all the time growing up. Ew. Floating poop in the water, and you have to go downstairs, and it was so, when I was a kid, it was so gross. But you get sick. You get diarrhea, cholera, typhoid, hepatitis. Why could I not say that word? Hepatitis A, malaria, dengue fever, more mosquitoes. I mean, just all of these bad things that happen from flooding events. And it doesn't seem like we're really concerned about it enough to stop building in the places, you know, where those effects happen. But we also, you know, ecosystem services are sometimes hard to grasp because the value that the forest and the wetlands and all that provide is, how can I explain this? It's kind of provided in the reverse. It's like if you didn't have this forest, wetlands, all those things, then you would have to spend this much money to retain that stormwater and all that. So it's like, you know, it's a budgeted item sort of. It's, you know, we got this money in the bank because we have trees and wetlands and all of this. We're saving money that the county doesn't have to spend in stormwater management. Does that make sense? So it still has value. It has a tangible dollar value on the spreadsheet. And that's what's never happened before. Before ecosystem services started to be talked about, it was always, you know, this piece of land, it's going to have a bank, and the bank gets, you know, pays this much in taxes and provides this many jobs, and, you know, and all this stuff. And I'm going, well, that piece of property where you want to build that bank is an irreplaceable wetland that's right adjacent to a stream system that's in one of the major corridors in our county on highly erodible soils. So what value does that provide? For the first time, that's making it onto the spreadsheet. We're not just looking at what the development value is, we're also looking at what the preservation value is. This is a radical concept, people, because we're saying, you know, when I was back in forestry school, we would do cost-benefit analysis, and we'd say, you know, is it going to make sense to timber harvest this, you know, 1,000 acres in the Rocky Mountains? I was like, yeah, it's all good. And at the time, we were screaming for, we're not talking about the impacts to the wildlife. How do you measure that? How do you put that in dollar values? And we can do that now. We have the technology with GIS and, you know, mass computers to be able to do those calculations. So it's really so exciting. This one is very hard to measure, of course. So the first two are pretty easy to measure. Provisioning services, how much food, how much wood, those kind of things. Regulating services, even clean water. We can figure out what the costs and benefits of those are. Cultural, spiritual. I just love these. The banyan trees just get so huge. You know, when you love trees like I do, everybody gives you a tree book for a present, you know, and I've got some of these just amazing, you know, trees that would take 10 people to go around, you know. That's spiritual stuff for people, you know. In this town, they put little idols at the base of this tree. This is connection. And that, you know, is something that we should be able to value. Supporting services are also a little bit difficult to calculate, but certainly something of value. And this is something, before I started studying this, I didn't really have a grasp on, is the nitrogen cycle. You know, I knew there was a carbon cycle and a water cycle, but I didn't realize that nitrogen also circulates through the ecosystem. So, you know, fossil fuels, whatever, goes up into the precipitation, it rains down. Organic matter has nitrogen in it, and then its mineralization becomes ammonia, nitrification. Uh-oh, now it's in a form that becomes available to plants. But when it becomes available to plants, it can also run off. So there's different kinds of nitrogen. So up here it's saying, you know, runoff, this is manure, you know, things that are going on, or fertilizers can run right off into water bodies. They can go down through the soil a little bit and go down into water bodies. And then once it breaks down even through this process, it can go into water bodies. What happens when nitrogen gets high? This is nitrogen and phosphorus are the two elements that we're fighting in the Chesapeake Bay. Let's talk about that for a minute, because these are really important current land use issues. So nitrogen N, phosphorus P. So let's talk about nitrogen for a minute. Too much nitrogen in the bay ended up doing what? What does nitrogen do? Makes plants grow. Yay! Get green, I grow, so
Algae bloom.
you get algae blooms, you get all this vegetation, it's like, woo, yeah, it's good, it's really cool. This is way oversimplification. But, so then all those plants grow, and what happens to the bottom of the water?
It's no oxygen.
There's no light down there. There's no oxygen being produced. And you know, I can't say I really understand the chemistry of what's happening, but nitrogen makes all these plants grow. It's really bad. Everything dies as a result. Phosphorus is similar. I'm not real sure, you know, locked in on how, what impact that has. Phosphorus grows roots, so it also aids in plant growth, so I'm sure it's a contributor as well. The problem with phosphorus is that it really moves in the soil. Nitrogen can be tied up in the soil somewhat. It's not always mobile. But phosphorus is pretty much always mobile. Does anybody remember when laundry detergent used to have phosphates in it? Yeah, really bad for fish and other things, so, you know, so have heart. We fixed that too, once we figured out that that was a bad thing. So definitely services going on. Carbon cycle, you know, we all kind of learned this in high school chemistry. You know, we've got CO2 in the air, and that gets taken up by plants through photosynthesis, and then the carbon goes into decay into the ground, gets released, or gets burned as firewood and gets released, carbon that way. And then, you know, long-time carbon deposits in the fossil fuels, dead organisms and waste products release carbon as they decompose. And, you know, then it goes right back up, and you can, you know, what's adding to the CO2, which is that's what's making this whole system out of whack, is that we're making too much CO2 and not taking enough in. Well, guess what? I used to have a bumper sticker for the longest time that said, "Trees are the answer." And of course people would go, "Oh, what's the question? Duh, duh, duh." The question is, who's going to save us? The trees are going to save us, I'm telling you. Because they can clean the air. And the more you have, the cleaner your air will be. It's a very simple equation, really. Okay. So, ecosystem services, are we done with that? We are, but I want to tell you a little more about this little study that we did. So here's our case study, real life, what's happening out in the world. We were pilot project working with the U.S. Forest Service, who developed software called iTree. Everything's I these days, right? So little I tree. And they have a whole bunch of other softwares that have spun off of that iTree. But they used that in conjunction with, we had mapped all of our forest and tree canopy coverage using a method called, I'm going to throw out so many acronyms in this, LIDAR, which basically all that means is a plane flies over at a very low elevation, and they bounce a radar beam down to the ground and back up to the plane, and it measures the heights of things. And then they rectify it by looking at aerial photographs and go, oh, those are trees, those are not trees, you know, and it was pretty accurate. So we did the whole county forest and tree canopy, and I know it's small, but this was the handout we did for the elected officials. So I know it's small, purposefully so. You don't need to zoom in and see if your house is in the map or anything. So that's 52% forest and tree canopy. We divided it up into those two things because guess what? They provide different ecosystem services. People who had been doing this in the past had just thrown everything together, and we said, no, they're different. So forest is at least 10,000 square feet of contiguous forest that's at least 50 feet wide. And you see how you can train a computer to tell you those things? You go into GIS and you say, I want all patches that are at least 10,000 square feet in size and at least 50 feet wide, and there's a whole bunch of buffer in, buffer out stuff that happens. And it shows you what's forest. And then anything else that had been designated green that was at least 6 feet tall, we called that tree canopy. So if it was a small little patch of forest or something, we just said, well, that's tree canopy, because that's not forest canopy with that robust kind of feeling. I think that helped the validity of this study. because we're 44% forest, 8% tree canopy. Well, the reason that we needed to measure it was in part because we'd had in 2005, with this other plan, we established a tree canopy goal of 45% based on the data we had at the time. So this was 2000. We were using this GIS stuff in 2000, and I'm looking at you because you know how GIS has changed over the last 10, 15 years. So in 2000, we thought we were, and this was projecting for growth and everything, we said 45% is our goal. American Forests says that 40% is a livable community. 40% should be a general goal for communities. So we were at like 48%, and we knew we'd have some growth and things would happen, so we set it at 45%. Oops. The technology got so much better, and we were able to measure it so much more precisely that now we have 52%. Doggone it! Wow, shoot, we met our goal, that's it, we're done, go home, it's all good. Yikes. So it's kind of, when the data came back, I was like, oh no, that's terrible. We have more than we said we had. So we had to find a way to make having more be a good thing and not, call so much attention to it. And then let the elected officials say, oh, our new goal is to maintain 52%. And that's the new goal that they just set. They're going to maintain 52%. So how are they going to get there? Well, we said, let's measure some ecosystem services. So this is air quality. And this is all the software did all this for us. We had to give them, population data and hook them up with the state health data. And there were things that we had to do to help get them information. But this says that the forest and tree canopy, that 52% of the county, removes 5,000 metric tons of pollutants every year. 5,000 metric tons of pollutants, with a service worth $21 million annually. So if you, chairman of the council, had to come up with $21 million every year to deal with air quality, to just keep it at the grade F that we currently have, that would be another $21 million that you'd have to find in the budget. Or we can preserve this forest and tree canopy. See how that works? It's brilliant.
What happens
So that-
to all the chemicals that go into the trees? Do they release it?
They break it down mostly through their leaves. Then they get, as leaves decompose. The pollutants are carbon and nitrogen.
Oh, those are the only ones
So-
you're talking about then?
Yeah, mostly, yeah, that's what they take in. Okay, so cleaner water, I think I said this already, $12.8 billion every year. They'd have to put on the expenditure side of the county budget if we didn't have forest and tree canopy. I think I said this when we talked about it before, I'd never seen elected officials pay attention when I gave a presentation ever. They're always like fiddling with their phones or doing something else. When I started talking about dollars, they were paying attention. I'll skip over the greenhouse gas emissions and just point to this one map. Again, communications, look at how bright those colors are. Yeah, what do you think the red means? Bad. Red is bad. Red means lowest tree canopy coverage and hottest with regard to, they have less canopy, so they're a hotter community. So we call this cooler communities. Studies have found that trees can reduce surface asphalt temperatures by up to 36 degrees Fahrenheit. We know that intrinsically, right? But to see it 36